This video we're going to talk about arc length and sector area. So we're going to be able to find out how to find the arc length of a circle or find the area of a sector of a circle. Let's do this in degrees. So let's talk about what arc length is. Arc length is kind of what it sounds. It's the length of the arc. So if we're talking about this angle right here, arc length will be the length of this arc right there that you kind of seen in red. So like this guy. So how do we do that in degrees? Well, what's the arc length measuring? It's measuring the circumference. So you get the circumference, which is 2 pi r, then you times by what portion of the circle you have. Theta over 360. And then you're done. There you go. You got your circumference and you times it by what portion of the circle you're actually covering. Done. How about for area of a sector? Well, it's the same idea. This area of a sector is only a small portion of this whole circle. So the same idea. How do you find the area of a circle? Pi r squared. Then you just multiply by what portion of the angle, the circle you have. So theta over 360. And that'll give you area of a sector. That's all good and great. But now B, we do this a lot with radians. So look, let's try to find this formula with radians. So arc length. Same idea, right? It's going to be theta over our angle times 2 pi r. Now, but remember in radians, what's 360 equivalent to? 2 pi. So you get this. 2 pi's cancel. And arc length in radians is just this formula. Right, it's a much simpler formula. You just get your angle in radians and times it by the radius. Same idea for area. Right? Area formula is this. Theta over the portion of the circle you have times pi r squared. But in radians, 360 is the same thing as 2 pi. So the pi's cancel out, and you get area equals 1/2 theta r squared. That's where you get these formulas from. So that's how you find arc length and area if you're given radians, which is generally giving the default. By the way, these formulas are in the formula sheet. So you don't have to memorize, you're just going to know how to use them. These will be in the formula sheet in radian form. They don't give them to you in degree form, they'll give them to you in radian form. So let's do an example. A sector has a radius of 12 centimeters and an angle of 3 radians. Find its arc length. So let's put down the formula. Arc length L is equal to r times theta. Right, just copying the formula right here. R theta times r, same thing. Well, what's the radius? The Hill's radius is 12, and tell me the angle is 3 radians, so I could use this formula. So it's just 12 times 3, which is 36. Easy enough. Let's find the area, same idea. Area is the following formula. 1/2 theta r squared. And likewise, my theta is 3, and my radius is 12. So I'm going to get 1/2 3 times 12 squared. So that's going to be 1/2 3 times 144. Half of that's what? 672. So I'm going to get 3 times 72, which should be 6 and 21, 216. Hopefully that's right. Please don't double check me. Alright, but that's the general idea. If I just want you to find arc length or area, just plug into the formulas and simplify. Well, this next one, it's kind of going a little backwards. The sector has a radius of 8.2 and an arc length of 12.3. So let me draw this one to give us a better idea. That. Let's have a little radius of 8.2. And our arc length is 12.3. So I'm just going to make up an arc length. So this is 12.3. My thing comes down. And I don't know the angle yet. That's right. So 12.3 is the arc length. There's my radius. I don't know the angle. Find its angle. Well, so what do we have? We have the arc length. So let's use that formula to find the angle. L equals r theta. What do I have? I have the L, 12.3. I have my R, 8.2. But I don't have my theta. I do not have my angle yet. So there's our equation. Divide both sides by 8.2. I'll sub that into my calculator, plug that into my calculator there, and get 1.5. So that's how I find, and that would be my theta, my angle, 1.5. So that's the angle. Now they want me to find the radius. Well, put down the formula. Area of a sector is 1/2 r squared theta. Sub in everything you have. So 1/2. R we always had 8.2. And now we have theta, we just found it, that's 1.5. Plug that all into your calculator to get 50.43. Now again, we're doing IB, so we prefer 3 sig figs, so 50.4 would suffice. Nice, 3 sig figs. Okay, let's go to the next one. So similar idea. A sector has an angle of 1.19 radians, that's my angle, and an area of 20.83. They want me to find the radius. Well, I have the area, so let's put down the area formula. Right, and plug in what I know. I have the radius is 20.8, I have the area is 20.8, and I have an angle of 1.19. So 20.8 equals 1/2 r squared times 1.19. So now this is some math problem. We gotta isolate r squared. So multiply 1.19 by 1/2 to get 20.8 equals r. Let's just say 1.19 over 2 times r squared. Right, now I gotta get r squared stuff, so I'm gonna divide by this from both sides. I'll use my calculator in a second, and then I'm gonna square root it. And I calculate, I get 34.957. And then you want to get r squared by itself, so this r by itself, so let's square root both sides. And again, you can see I already did it, it's 5.9125, or r equals 5.91 if we're using 3 sig figs. So that's my radius. Now let's talk about a thing that comes up sometimes, and we don't really hear it that often though, if you're not an IB. It's the perimeter of a circle. What's the perimeter of a circle? So let's talk about that. So here's my circle. Radius is 5.91. My angle is 1.19, so let's, again, since I estimated, let's say it's right there. The perimeter circle is when it's kind of, let's say you want to enclose animals in there. It's the 2 radiuses plus the arc length. That's a perimeter of a circle. So the perimeter of a circle is this spot plus this spot plus the arc length. Right? It's like the fencing around that arc. So that's all perimeter circle is. It's radius plus arc length. So let's plug them all in. The radius is 5.91. Same thing with the radius right here, 5.91. Radiuses are always the same value. And the arc length I actually haven't found yet. What the formula for it is r theta, and I have both of those. R is 5.91 I just found, and theta is 1.19. And that's your perimeter. Just multiply it all in your calculator. You'll get 18.8429, or 3 sig figs, 18.8 approximately. So that's how that one's done. Look at this next one here. A little review of geometry. AT is a tangent to the given circle, so that's a tangent. OA is 13, so let's write that. O to A is 13. And the circle has a radius of 5. So that means that this is 5 and this is 5, which means this is 8. Not sure if I need it, just writing stuff down, I know. Find the perimeter of the shaded region. So I'm going to find the perimeter of the shaded region. So I'm going to add this line, and that line. So here's the part that's a geometry review. If you have a tangent to a circle, the tangent and the circle make a right angle. So if you have a tangent and a circle, they make a right angle. So really what I have up here is a right triangle of 5, right angle, and 13. So I gotta figure out what this side is right there. If it's a right triangle, I'm going to do a squared, b squared, c squared. And a 5 flank 13 triangle should be one we all know. And that is 13. It's a rad triple. So be 25 and 169. Subtract 169, you get 144, square root that, and b equals 12. It's a 5, 12, 13 triangle. One of the classics. So now I have the length of this guy. Remember, they want the perimeter, so they want like the perimeter of the shade region. So that's going to add this line with this line plus the arc length. So my perimeter is going to be 8, which is this line right there. Right here, sorry. Plus the outside line, 12, plus the arc length L. But again, we know how to find arc length. It's just the formula for it. It's R times theta. So 8 plus 12 plus R times theta. Now one of these is easy. That's R. R is 5. Theta, I just realized you gotta know some trig. We haven't really talked about trig yet, but let's do it anyway. So how am I gonna find theta, which would just be this angle right there? Well, that's a right triangle. If you remember your trig and right triangles, there's SOHCAHTOA. Right now we have we can actually use any way we want, but here's opposite and here's hypotenuse. Doesn't actually matter which one you use. I'm gonna use sine of theta equals 12/13. And since I want to find what theta is, I'm gonna do sine inverse of both sides. And I get theta equals something in my calculator. Now, something that's very important, something I for my calculator, is that since we're using this formula, the R theta formula, that only works in radians. I have to make sure my calculator is in radians. So I'm gonna go to mode, look at the third one down, radians is highlighted. If it wasn't, let's say degrees was, easy to fix, you just go over to degrees highlighted, you just go over to radian, and you press enter. Now it's in radians. So I'm gonna quit. Now remember, the only reason I'm using radians is because my formula I'm using here is in radians. I have to make sure I'm in radians. So sine inverse of 12/13, second sine, 12 divided by 13. And I get about 1.176 radians. So again, that's in radians. Now I can put them all into here. 8 plus 12 plus radius is 5 times 1.176. And that answer will give me the perimeter. So in the calculator I got 25.88, or 3 sig figs, 25.9 roughly, approximately. So that'll be the perimeter of this little thing right there. So a couple more and then we finish. So this is from here. It wants to find the angle first and then use that angle to find the area. So we gotta find the angle first. Then we gotta find the area. So the angle, well, look what we have. We have the arc length, we have L. So let's put down a formula. L equals R theta. So we're gonna type in L. L is 8.4 equals R, which is 5 times theta. Then it's divided by 5. And theta is an equal 8.4. This 1.68. So again, that's my angle in radians. So there it goes, 1.68. Now if I want the area of the sector, I'm just gonna use the area of a sector formula, which is 1/2 R squared theta. Or if you don't remember, it's in your formula sheets. Look at it. So I get 1/2. My R is 5 squared, and my theta is 1.68. And I'm just gonna type that all into my calculator to get 21. Hey, look at that, nice clean number.